Howdy, this is Mr. Russell's chemistry on naming ionic compounds in the crisscross method. So something I might not have been clear on before is that these over here on the left side, where these symbols are called the chemical formula. Okay, they are called the chemical formula. And over here we have what's called the IUPAC name, or just the chemical name. This is just the chemical name. Okay. And it's IUPAC comes from the International Union for Applied Chemistry. It's French, so that's why the A and the P are backwards. It's the International Union for Applied Chemistry. So I'm going to do number 13 first. We have Na2S. It's an ionic compound between a boy and a girl. And we have two metal atoms and one nonmetal atom. But the numbers don't really make a difference when we are talking about the chemical names. Most of the time. It won't make a difference in this one, and I'll show you why. This one will just be sodium sulfide. This one will just be sodium sulfide. Okay, I changed sulfur to sulfide because in an ionic compound, the nonmetal will change its name to end in "ide." Okay, so sulfur changes to sulfide. Now remember that in a marriage, the girl will change her name a lot. So if that should make sense that the non-metal, the girl, will change her name. Okay, over here. So if you can remember that. Nothing goes in the middle because sodium over here only has one charge. It only has one oxidation state. These oxidation states should be in your notes. You'll be using these a lot, okay? Come back to these a lot. You want to come back to these common oxidation states. Okay, sodium only has one oxidation state, and sulfur has one oxidation state. Okay, so let's go back to over here. We have iron in, let's go to number 10. So we have iron, Fe, and bromine. We have 3 bromine molecules. I'm going to erase this junk right here because it is a little crowded. So we have iron, which is our metal, so it's our boy. We're a good chemist, and we know that iron is Fe. And we have bromine, okay? So we will put bromine will change its name to bromide. Okay, to bromide. Now, we'll probably have to put a Roman numeral in the middle here, okay? And I'll show you why. When we look at the oxidation states for Fe, we have the oxidation state of 2 plus and an oxidation state of 3 plus, okay? So there are 2 different oxidation states. We have to choose which one, and we can do it. We can do it. If we go and we see that iron could either be a 2 plus or a 3 plus, which we just looked up, and bromine is always going to be a 1 minus right here. Okay, so if bromine is always going to be a 1 minus, we will have 3 negative charges here, okay, to balance everything Well, to get a net charge of 0, we will need 3 positive charges. So we will need iron 3 bromide. Okay, y'all might have been able to figure out that you can really just borrow the number from the other symbol. Okay, remember this 3 over here will give you a clue as to what will be over here. Okay, most of the time, most of the time. Unfortunately, that can't be the rule all the time, and we'll find that out in this one, number 11. When we have PB, which is our boy, and S, which is our girl. The boy always goes first, and the girl always comes second. So, if we have PB, and we know, because we are good chemists, that PB is lead. And we will have our girl, which is going to be sulfur, but sulfur will change its name to sulfide. Okay, you should be noticing a pattern that they all end in "ide". Okay, they all should end in "ide". We will need a Roman numeral here again because we'll have to go back to our common oxidation states, find lead. Can you find lead? It's right here. There is a 2 plus and a 4 plus, 2 plus and 4 plus. So it could either be a 2 or a 4. We'll have to choose which one. Now, we have sulfur right here. Sulfur is a 2 minus, okay? We only have one sulfur atom, okay? This one is understood. So we have, oops, I'll erase that. We have, uh-oh, where'd my pen go? Sulfur, and it has a 2 minus charge, and we only have one of them. So we only have one 2 minus charge. So we have a total charge of -2 for the nonmetal. So we need a charge of +2 for the metal. Okay, that leads us to believe that lead 2 is going to be our answer, and that is the correct answer. I'll let y'all work these out some more. But I want to talk about the crisscross method. Alright, the way we want to do this, real quick, the crisscross method is a pretty simple way to do it. Is if we take something that gives us the IUPAC name. Remember that these are the IUPAC names. If we have the IUPAC name here, and I want the formula over here. I want the formula. So if I have iron 3 chloride, okay, we don't have to go hunting for our oxidation states. I gave them to you. It's right here. Okay, so I know that iron is Fe because I'm a good chemist, and you should be too. I know that iron is Fe. If you forget, then you always have your periodic table in front of you, and you can find it. You can figure it out. This has a charge of 3 plus. I gave you the oxidation state. And we have chloride. So we have chlorine right here. And its oxidation state is, well, I don't know it, so I'll have to look it up. Can you find it? My cursor's pointing right at it. It is -1. So I will have -1. I want you to do the crisscross method. So what you will do is take this number, put it down here. Take this number and put it down here. Sorry, my lines aren't very straight. And we will put them together and end up with iron, Fe, with this number at the bottom. So this number at the bottom would be a 1. Okay, we'll drop the charges, and we'll end up with chlorine with this number at the bottom, which would be 3. Now, in math, just like in math, whenever you have something like 1x, they'll very often just drop the 1. Okay, those 1s are considered to be understood. So we will, in chemistry, we'll do a pretty similar thing where we'll just write FeCl3. Okay, let's do one more. If we have, let's do number 18. We have copper sulfide. So if we have copper, which a good chemist knows that copper is Cu, and its oxidation state is given to me right here. I will take a 2 plus right here, and sulfide, I'll look it up, and I'll find out that sulfur or sulfide is going to be a 2 minus charge. So I'll take sulfur with a 2 minus charge. I'll do my crisscross method again. This number comes down here, and this number comes down here. I'll end up writing copper with this number down here, 2 sulfur with this number down here. Okay. Now, if you get in a situation like this where you can reduce it to the least common denominator, you should. There is a least common denominator right here. You can divide these two numbers by 2. Okay, so you should divide them by 2. So we would just end up with copper sulfide. Okay. Before, we did not have a least common denominator. All we had is 3 and 1, and we can't divide them at all and still get a whole number. So that's why we didn't divide up here at the top, but we did divide down here because we can divide and still get a whole number. So, do you understand it? Well, hopefully you do. Finish these practice problems, and you'll be able to for your 9 weeks, be prepared for your 9 weeks test on ionic bonding naming. Good luck.